purpose of this experiment is to model Newton's second law, this time with a falling object, a headband, and an F-net not equal to 0. The results of this experiment indicated the computer Python code was extremely accurate in its predictions of the experimental positions of the headband during the time interval. I videoed a headband weighing about 0.04 kilograms being dropped from a height of 1.615 meters, the height of my roommate. The video frame rate was 30 frames per second, lasting 19 frames and a total of 0.633 seconds. The clip can be seen here. From this video and the experiment, we know the initial position to be 0, 0, 0 meters and the initial velocity to be 0, 0, 0 meters per second because the initial position was chosen as the axis in the origin at 0, 0, 0, and the initial velocity because the headband was dropped from resting. This info was imported into VIDLE and the Python code. The mass of 0.04 kilograms is seen here. The initial position and velocity vectors are here. The gravitational constant, 9.8, is here. And J hat, the direction of the weight force, in this case, the unit vector in the positive y direction, is here. If you run the code currently, the only force acting on the system would be the gravitational pull, or the weight force, an F-net equal to 0.392 newtons. As you can see in this graph, with only weight force taken into consideration, the Python model overpredicts the position of the headband tremendously, as seen in the gap between the experimental and the model position lines. I then run the code with drag force taken into consideration along with gravity, as seen here. The F-net with the weight force and a drag force. The drag force is the blue arrow, and the yellow arrow is the gravity weight force. The greater magnitude of this yellow gravity arrow is why the headband continues to fall until it reaches the ground. As the headband speeds up, the magnitude of the drag force is more significant. Therefore, that is why in the beginning there was no drag force. When plotting the Python code data with gravity and drag as components of the net force, the computational data almost perfectly represents the experimental data from Tracker. This graph with drag and weight forces included in the F-net has a terminal velocity when the headband ceases to accelerate and falls at a constant speed, where the drag force is equal to the weight force. This is the terminal velocity, and it can be found in the graph here, where the lines begin to straighten out. If the headband was initially thrown downward, the terminal velocity would be greater because there would be an additional force from my hand throwing it downward. Possible error encountered in this lab was I had to guess the mass of the headband because I did not have an accurate scale to weigh it. In conclusion, by consideration of Newton's second law with an F-net composed of a drag force and a weight force, the computational model accurately predicts the positions of the headband against the experimental data.